Okay, questions 16 and 17 use the method of partial fractions. So here we have a denominator that's factored, and we're going to break it up into two fractions as follows. We'll write this as one fraction with x in the denominator and the other one with the other factor x squared plus 1. And since x is a linear factor, we put a above that, and above the quadratic factor we put a linear bx plus c. Now if we multiply both sides by this denominator, we have 1 on the left-hand side, and on the right, okay, let me just show the multiplication. We're multiplying by x times x squared plus 1 on both sides. So on the right, when we do the multiplication, the first fraction times x squared plus 1, the x's cancel, and we're left with a times x squared plus 1. And when we multiply the second fraction, the x squared plus 1's cancel, and we're left with this numerator, bx plus c, times x. Now let's just multiply through here. We have ax squared plus a plus bx squared plus cx. Okay, now we do what's called matching coefficients. So on the left, we have a coefficient of 0. We have no x squared term, so that would mean a coefficient of 0 for x squared. So matching the x squared coefficients, we have 0 on the left, and on the right we have a plus b. All right, next we match the x coefficients. We have no x coefficient on the left, so that's 0. And on the right we have only c, so we see we have c is equal to 0. And now the constant. On the left we have a constant of 1, and on the right we have a. So a is equal to 1. C is 0, and according to this, if we subtract a, b is equal to minus a, so that means that b is minus 1. Alright, so now we're ready to write our integral as a sum of two fractions. Alright, so we have 1 over x, that's a over x, a is 1, plus b is minus 1, minus 1 times x, that's minus x, plus c, but c is 0, over x squared plus 1 dx. Alright, so this we can integrate pretty easily. We have two log integrals. The first is log x, and the second, here we have a minus sign because of this. The second is log of the denominator, and we're missing the derivative of the denominator is 2x. We're missing the 2 up here, so we'll put a 1/2 in front. Okay, let's look at our next partial fraction integral. Okay, we're looking at number 17. So we have 3x squared plus 6x plus 11 divided by x plus 1 times x squared plus 2x plus 5 dx. Now the denominator is factored as much as possible. This does not factor. In fact, b squared minus 4ac is less than 0. So we can't factor this. Alright, so let's split this up as is. So we have on the left side, we'll write 3x squared plus 6x plus 11 divided by x plus 1 times x squared plus 2x plus 5. and we're going to split this up. First we have a linear factor, put an a over that, and a quadratic factor. Sorry, that's a 5, x squared plus 2x plus 5. And we'll put a bx plus c over our quadratic factor. Now multiply both sides by this denominator. So on the left side we have 3x squared plus 6x plus 11. And on the right side, when we multiply by this denominator, the x plus 1's cancel, so we're going to get a times x squared plus 2x plus 5. And when we multiply this by this denominator, these two will cancel, and we'll have bx plus c. We'll be left with bx plus c times x plus 1. Now let's multiply out this right-hand side. So we have ax squared plus 2ax plus a times 5. And now let's multiply out bx plus c times x plus 1. So we have bx squared plus bx plus cx plus c. Okay, and on the left we still have 3x squared plus cx plus 11. Now we'll match coefficients. Okay, so here x squared. We have 3 on the left. So 3 is equal to a plus b. Okay, now let's look at x coefficients. So here we have a 6. 6 is equal to 2a plus b plus c. Okay, now constant. 11 is equal to 5a plus c. Okay, so let's see what we can do with this. Well, first, here, if we subtract these two, we'll get rid of c. So maybe we'll just do that. Take these two, and we're going to subtract them. All right, let's say we subtract the bottom minus the top. Okay, so we'll do, or maybe we'll do the top minus the bottom. So 6 minus 11, that's minus 5. And 2a minus 5a, that's minus 3a. And c minus c is 0, but we have the b is still there. So we get this equation with a and b. And here we also have an equation with a and b. So we could subtract these two equations. So let me write this one down. Here we have, write this one right on top here. We have 3 is equal to a plus b. So now what we want to do is we want to get rid of the b. Okay, so we could subtract these, or if you want, we could just multiply this by minus 1 on both sides. Okay, so let's say I would change that to a plus, change that to a plus, and change this to a minus, and add. So here we have 8 is equal to 4a. And these cancel. So that gives us a is equal to 2. Okay, so finally we have one value here. A is equal to 2. All right, so in this equation we can substitute a equals 2. If we put a 2 right here, subtract from both sides, we get b is equal to 1. All right, let's substitute in here, and we'll get c. So we're going to substitute a 2 right here. 2 for a. So we have 10 plus plus c is equal to 11, so that gives us c is equal to 1. All right, so now we're ready to split up our integral. And okay, a is 2, so we're going to have 2 over x plus 1. And then here we're going to have x plus 1. Okay, b is 1 and c is 1. Okay, so let's do that. So here's our integral. We have 2 over x plus 1 plus x plus 1 over x squared plus 2x plus 5. Okay, see that? X squared plus 2x plus 5. All right, now the first is obviously a log. This is 2 log x plus 1. And look at the derivative of the second denominator is 2x plus 2, which is 2 times x plus 1. You see 2x plus 2, which is 2 times x plus 1. So the derivative of the denominator is sitting in the numerator except for a 2. So this is another log. Okay, to make up for the missing 2, we have a 1/2 there in front. And this is another log of the denominator.